So today we're going to go over Unit 3, Reading, Measuring Tools, and Using Scales. Our goal today is to understand our customary ruler. We're not going to spend much time on the metric in this class. We will touch a little bit on converting between customary and metric units, just some very basic conversions. And then we're also going to talk about scale reading. So in our fractional ruler, there are some major divisions, both feet and inches. And there are major divisions of each inch. There's a half inch, a quarter inch, an eighth inch, and a 16th. So here you can see those divisions labeled. And additionally, here's a short video on reading that fractional ruler. So the first section of your text in the chapter talks about a fractional ruler. And so it's important for us to understand the divisions in a fractional rule. So what you'll see here is that there are large numbers with a line that goes from top to bottom of this fractional rule, and those denote each inch. And what you'll find is that each inch is divided into 16 increments. So let's go ahead and count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And what you'll see is that the tick marks between the inch marks vary in length. So you'll see here that the halfway mark is the next longest tick mark, and that denotes our half-inch increment. And we know that's our half-inch increment because we have 16 tick marks between each inch increment. And if I count over 1, 2, 3, 4, 5, 6, 7, 8, I know that is 8 out of 16, which reduces to 1/2. You'll also see that there are tick marks that are a little bit shorter here and here. And so if I go ahead and look from the inch increment to the half-inch increment, I notice that this is the halfway point. So if I count over again, 1, 2, 3, 4, I know this is 4 parts out of 16, which means if I reduce that, it is my 1/4 inch, 1/4 inch mark. And I can continue to divide smaller and smaller. If I count over 1, 2, I have 2 over 16, which means that is my 1/8 mark. When we're converting English to metric, we have some basic units of conversion. 1 inch equals 25.4 millimeters, or 1 inch equals 2.54 centimeters. So an example of those would be converting 14 inches to millimeters. I would use my conversion factor of 25.4, multiply it by the number of inches, and come up with my final answer. Additionally, if I was changing inches to centimeters, I would use my conversion factor of 2.54, multiply it by the number of inches, in this case is 9, and come up with my final answer. We've talked at length about drawing scale, and you've had a little bit of that in your intro class as well. But we create our construction drawings at a reduced scale. And we either do that with an architect scale or an engineer scale. The example in our text here is that an architect scale for every 1/4 inch equals 1 foot, and that means every 1/4 of an inch equals 1 foot of actual length. And that holds true for each different scale, whether it's an eighth, whether it's 3/32, etc. An engineer scale means that for every 1 inch on a drawing scale equals a certain number of feet. So you have a 10, 20, 30, 40, 50, and 60 on your engineer scale. And that means for every 1 inch corresponds to a certain amount of feet in reality. So here's our engineering scale. If you have one in the drafting kit from our department, it'll say engineer on it. So that's our first hint that this is our engineering scale. Another way that you'll know it's an engineering scale is you'll see that there are increments in multiples of 10, which denote the scale. So the scale marker is right here. So I have 10, 20, 30, and on the other side, I have 40, 50, and 60. So there are 6 different scales on our engineering scale. So we know that when we talked about the concept of scaling, that we can't fit a piece of property that is 500 feet by 400 feet on a 24 by 16 or 24 by 36 piece of paper for our drawings. Obviously, that would exceed the limits of our paper. So what we do is we scale that down proportionally so it fits. So the 10 scale means that for every 1 inch on the scale equals 10 feet. So if I have 1 inch on my scale, that means that this 1 inch increment from here to here equals 10 feet on my drawing. Likewise, if I choose the 20 scale, that means for every inch I have stands for 20 feet. And what you'll notice is at the 0, instead of it going to the 10 or the 1 marker, my same 1 inch line goes all the way to the 20. So you'll note that the tick marks get closer together, and that denotes a smaller scale. Likewise, on our 30 scale, you'll see that that same 1 inch increment doesn't land at the 10 or the 20, but it lands at the 30 tick mark right here. So that means that for every inch on my 30 scale, that equals 30 feet. So let's go ahead and practice, and we're going to measure some lines. And this activity is found in your textbook on page 55 if you'd like some additional practice. So we're going to start with this very first example here. It says to use our engineer scale, and we're going to measure the following line. So some things that we need to keep in mind when we're using a scale is that we need to make sure that we are lining our numbers up with the 0 and not the end of the scale. So if we look here, what I see is that my 0 starts right here, but the end of my scale is all the way over here. So I'm gonna go ahead and zoom in a little closer. Hopefully we can get this focused for you. Let's take a look. There we go. Oh. So now that this is a little bit more focused and close up, what you can see is that the 0 mark doesn't start at the end of the scale. So if I wanted to measure something and line it up, I wouldn't start at the end of the scale here. I would need to start the end of my line right here at the 0. So for this example, for this line, if I was trying to line it up, I wouldn't want to start at the end. I would want to slide it down so the end of my line corresponded with the 0. Once I do that, now I'm ready to measure. So if I zoom back out a little bit here, there we go. So the first thing I'm going to do is line up the 0 with the end of the line. And now I'm going to go ahead and count across. So I'm going to use my 10 scale, and my directions told me that I needed to use the 10 scale to measure the length of this line. So I have from 0 to 1, that's 10 feet, because for every inch equals 10 feet, 20 feet, 30 feet, 40 feet, and then between each 10 increment, each tick mark is equal to 1 foot. So I've made it to 40 feet, and then I'm going to count individual tick marks to the end of my line. So 41, 42, 43, 44. So using a 10 scale, the length of this line is 44 feet. Moving on to our next example, 1 inch equals 20 feet. So that means I'm no longer using the 10 scale. I'm going to flip my scale and find the scale that has the 20 increment. So again, I'm going to line up my scale with the 0, not the end of the scale. You'll want to line it up with the 0. And I'm going to read my scale across. So I've got it all lined up. So 10 feet, 20 feet, 30 feet, 40 feet, 50 feet, 60 feet, 70 feet, 80 feet. And it doesn't look like I make it all the way to the 9. So now I'm going to count individual tick marks. 81, 82, 83, 84, 85, 86, 87, 88. So my line stops at 88 feet. The same holds true for each scale on the engineer scale. So our next example says to use the 60. So I'm going to turn my scale around and I'm going to find the 60 scale. So you'll notice on the 60 scale, our tick marks are getting so much closer together. And that means that for every inch, we're representing more feet. So instead of 1 inch representing 10 feet, where our tick marks were further spaced apart, now 1 inch represents a full 60 feet. So our tick marks have gotten much closer together. So to read this 60 scale, you're going to go ahead and line up the end of that line with the 0, and we're going to count across the same way. So it looks like I have 40, 80, 120, 130, 140, and it looks like I'm ending up almost at the 150, maybe the 149 tick mark. So I would take either 149 or 150 for this answer. And so as you work your way through this activity for practice, you'll gain confidence and you'll continue to develop your scale reading technique. Reading the architectural scale is a little bit more complicated. If you recall on our engineering scale, we had 6 scales to read, a 10, 20, 30, 40, and 50. And that meant each side of the scale had 1 scale on it. But if we look at our architectural scale, you'll note that there are 2 scales on each side. There is a 1/8 on this side of the scale, but you'll also notice that there is a 1/4 that runs the other way. So you'll have to read left to right or right to left depending on what scale is specified. So what we'll see here is that the architectural scale looks a little bit different than the engineering scale. So if we recall, the engineering scale, we'll use our 10 scale as an example, starts at the 0. But what we'll note in our architectural scale is that we actually have some numbers to the right or to the left of the 0. We have some tick marks here. Let me go ahead and zoom in so you can see that a little better. So you can see that our architectural scale has the 0 tick mark right here, but we have some additional tick marks that go beyond that 0, and those stand for inches. Now, in our engineering scale, when we're doing civil plans and things like that, we usually don't measure things down to the inch. If I have a property boundary and it's 500 feet 1 inch, it doesn't make that big of a difference in the overall grand scheme of things. However, if I have a kitchen cabinet design and I'm off by an inch, that means that cabinet probably isn't going to fit into its specified area. So our architectural scale is more precise and more detailed than our engineer scale. So let's go ahead and take a look at what these mean. So one of the first things you need to do when you're reading an architectural scale is make sure you're reading the right scale. So if you remember, we have the 1/4 inch scale going this way, but we also have the 1/8 inch scale coming back the other way. So we need to make sure that we're first reading the correct scale. And the way we do that is we make sure that we always count up from 0. So it doesn't make sense to go from 0, 92, 88, 84, right? I'm counting backwards. I need to make sure that I'm counting up from 0. So 0, 2, 4, 6, 8. So you'll see these larger numbers are associated with a larger scale, and that's another reminder that you're reading the right scale. So for the architectural scale, I'm going to do the same thing that I did with the engineering scale. The first thing I want to do is line up the end of my line with my 0. And you can see that right here. So I don't want to line up with the very end tick marks over here. I want to line it up with the 0. And now, just like how I read my engineer scale, I'm going to read the feet on my architectural scale. So 0, 2 feet, 4 feet, 6 feet, 8 feet, 10 feet. And I'll go ahead and zoom out a little bit so we can see the rest of the line there. So 0, 2, 4, 6, 8, 10, 12, 14, 16. And you'll see here, it doesn't look like I've quite gotten to the 18. So 16, this halfway tick mark would be the 17, and then 18. So I haven't made it to 18, which means I need to slide my scale and line up the end of this line with the 17 tick mark. And what you'll find that does is that if I look back over to this side, now you'll see that my inches are in play. And I'll go ahead and zoom in so you can see that a little bit better. So now, even though I lined up my scale with the 0 at the beginning to get to 18, what you'll see as I slid it over to 17, now I have inches that I need to read. And what you'll see is that, so every scale has different inch increments. So regardless if it's a 1/4, if it's an 1/8, if it's a 16th inch scale, the 0 to the end inch increments always equal 12 inches. So I can know how many inches each tick mark stands for by counting them. So if you'll look, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I have 12 tick marks and all of those tick marks need to equal 12 inches, I know that on my 1/4 inch scale, each tick mark is equal to 1 inch. So if I line this back up, what I'll find is that my line ends at about 17 feet, 1, 2, 3, 4, 5 inches. So 17 feet, 5 inches. Let's go ahead and practice with the 1/8 inch scale. So the 1/8 inch scale is on the other side of the 1/4 inch scale. So just go ahead and slide that down. And so it tells me to go ahead and measure this line right here using this scale. So 1/8 inch equals 1 foot. So again, if I take a look at my scale, I don't want to line it up with the end of the scale or the end of the tick mark. I want to line it up with the 0 that's on the scale. And again, since I have the 1/4 inch scale running this way and the 1/8 inch scale running this way, I need to make sure that I am reading the right scale. So again, I always count up from 0, 0, 4, 8, 12, etc. So I'm going to go ahead and line my scale up with the 0, and I'm going to start to come across and look that it looks like my line doesn't quite make it to the 36. So what I'm going to do is slide it back to the 35, but it looks like it's actually landing on the 35. So my answer for this question is 35 feet. The other thing I want to draw to your attention here is that your inch increments are different for each scale. So if you recall, each tick mark on our 1/4 inch scale stood for 1 inch. Or each tick mark, on our 1/4 inch scale stood for 1 inch. But here, if I look at the 1/8 inch scale, I don't have 12 tick marks anymore. If you count them, 1, 2, 3, 4, 5, 6, I have 6 tick marks. So if I know that from the 0 over, this has to equal 12 inches, and I only have 6 tick marks, I know that each tick mark represents 2 inches. So on an 1/8 inch scale, I'm actually unable to measure anything more precisely than down to the nearest 2 inches. In your textbook, there's also a very helpful chart that talks about inch increments on your architectural scale, and that is found on page 42. And it lets you know what the smallest tick mark, how precise you can measure on an architectural scale.